So simulating data to improve your research part 1.5. We've done a fair bit in Excel, and that's useful for just sort of in a very simple way, getting you used to the concepts that you can apply when you're trying to simulate data. But it's not really so handy if you want to take simulation seriously and do a lot of it. The huge benefit of simulating data in R is that you can write a script that will then execute commands to generate data, and you can then run it many, many times and you can store the results. It's much, much faster than Excel, and importantly, it's reproducible. So you can keep your script, and there might be an error in it. There usually is an error somewhere in most scripts. So if that isn't the case, that can be found out because you have got a record of what you've done. This is in fact true for, it's a general principle in science that one should be reproducible and keep records. But in a lot of statistical practices, people don't do that. They tend to use just menu-driven software, which is not reproducible. You can also in R generate all sorts of different distributions. We've worked with the normal distribution and we'll continue to do that, but there's much potential for branching out to different sorts of distributions which may be suitable for some kinds of data. You can look at things like correlated variables, which are possible to do in Excel, but much harder. R has very powerful plotting functions, and we'll play with just some simple ones of those. And also, if you're thinking of learning R, which I thoroughly recommend you to do, it's a good way in to start playing around with simulations. And I'm going to assume you don't really know much about R at all. So if you do, this might seem too easy for you, but hang on, it does get more complicated. The downside of doing things in R is that there is a steep initial learning curve. R has some quite irritating peculiarities that are not always terribly obvious or intuitive to people. And you'll make a lot of mistakes. But the main thing is not to be discouraged by the mistakes, because all people who do scripting in R make mistakes all the time, but it's how you learn. You get something wrong and then you remember it once you've worked out how to get it right. You just have to go through that learning curve and things become more natural over time. But even for very experienced people, most programmers are Googling all the time. You can't remember all the commands, you can't remember the formatting of something or how to do something. You just Google, and there's so much free material on the internet that you can typically get your free advice from the whole world. So you're not on your own, even though you might feel rather daunted by it. So what I'm going to suggest is that you create a directory or a folder on your computer to save your work, and you should have RStudio and R installed. So just double click on RStudio to fire it up, and we'll try and do a little bit in R. What you should see, I've suggested that you should have downloaded and saved a script from Open Science Framework, which is a little introductory script that I wrote to get you going on simulations. So if you open that, it should appear on your screen up here in something that's known as the source pane. It's the source of the script. And the script sits in one pane. This is one of the slightly confusing things with R when you start out. There's so many different things to look at. So you've got one pane where you keep your script. Then down here, you've got the console, which is where you can interact live with R. And then over here, you've got a pane that you can select between different things, but environment is a very useful one. And then again, another set of panes down here, which you can toggle between. And we'll be playing with some of these. They may be in different positions on your machine, depending on how it's been set up. But you should hopefully be able to identify all four types of screen. And I'm now going to hop out of PowerPoint and go directly into R, where I've got my own screen visible like that. And I'll be oscillating between PowerPoint and R. So again, the PowerPoint slides will be available if you want to work through this more slowly on your own. So we're going to try out stuff on the console where you can type a command and just see the result. And we're going to try and just copy what we did in Excel. So we create random normal variables. So there's a command to do that in R, which is rnorm. So this little pointy thing in the console is just telling you that it's ready to take next input. You don't have to type that in, it appears magically. So we type norm and open a bracket. And in fact, let's just put rnorm 10. And you get 10 random numbers. I'm using one of my older computers, which doesn't do what the slides say you should see. If you've got a more up-to-date version of R installed, you'll probably see when you type rnorm open bracket, this little yellow box popping up, which is telling you what arguments rnorm needs. It needs to know how many numbers you want to create, that's n, and then what the mean and standard deviation of the distribution are. Interestingly, the mean and the standard deviation have already got values assigned. And that means that if you don't type them in, it will assume that those are the values to use. They're just a regular z-score, mean 0, standard deviation of 1. So you can omit them, but if you want to specify them, you specify them as the next two things after the commas. So we've typed rnorm 10 over here, and we've now got 10 just z-scores, basically random normal numbers. And yours will be different because everybody's are different. If I do it again, it will be different again. Every time it runs, it's just selecting at random. Okay, so if we then carry on, we want to actually keep random numbers, particularly when you're scripting. You don't just want them to pop up on the screen, you want to be able to do things with them. And so you assign them. So you give them a name, and then a variable can be a single number, it can be a vector of numbers, it can be a whole data frame, which we will see later as like a big worksheet. And we'll just call it my scores. So instead of just typing rnorm 10, we're now going to type my scores rnorm 10. And nothing pops up when you do that, as you see, but it's not that it hasn't happened, it's that it's been created, but it's saved now in your environment. And you can see in the environment now, our scores is there. And if my scores, and if I type my scores, back they come again. And that will always be the same because it's now been assigned. It's not recomputing it every time you type that. This little thing here, this backward arrow, is one of R's peculiarities. You could type equals here, but our aficionados prefer that we use this thing called an assignment operator, because equals in computer language can be rather ambiguous. You might come across this later on. And so most people prefer to just use this backward arrow, which means that my scores takes the value of rnorm 10. Okay, so back to PowerPoint, what are we saying here? And yes, I've said this, that you can see the contents by typing the name. Okay. So if we want to do what we did in Excel, we need also to have like a column of numbers that tell you whether you're in group 1 or group 2. And I've suggested up here that you can do it this way. There's also, most things in R you can do many, many different ways. But here, let's just paste that in. And then we find that my group has now popped up in the environment, and it's there. You can see it. So we've created a little vector which has got 1s and 2s. This C means concatenate, and it's a way of just bolting together either numbers or characters in a vector. So C has that particular value in R that it's not just another variable, it's actually an operator. Now we can then go straight and do a t-test, because we've got group identity for 10 values, and we've got the 10 values. And we can do it, again, there's various ways you can do things in R, but this is one way. And what I've put up here is my scores, and then there's this tilde sign, my group, which means my group is treated as the independent variable. If there's more than 2 values in my group, this command will balk, and it will tell you you've got more than 2 and it can't do a t-test because you just need 2 groups. But this is saying this is what the dependent variable, that's the independent variable. And the tilde is used a lot in R, it's used in regression, in other things, in this sort of way to differentiate essentially between the dependent variable and the independent. And we get a lot more output than we got in Excel. We get the t-value, the degrees of freedom, and the p-value. The reason the degrees of freedom is fractional is that this is not your standard t-test, it's the Welch t-test, which doesn't assume equal variances between the two groups. But you could opt to assume equal variances if you wish. These are options also that we saw in Excel, but we didn't really go into them. But this is like that last option that Excel gave you to do a Welch t-test. And this is just for the case where the groups don't have equal variances. And this will give you fractional degrees of freedom. Gives you a confidence interval for the difference between the two groups. And it gives you, yes, this p-value, and it gives you the means of the two groups. So that's fairly straightforward. Let's just go back down here then. So I think at this point, I've put a good point to take a little break for you to just explore. This is the way you learn R. It's not just by doing what somebody tells you to do or reading a book and following it exactly. It's by tweaking. So I've given you some very simple introduction to things that you can do in R, but you can then tweak it further. You can find out more about options for the t-test. You can do this through R's own help, but often R's help is very comprehensive, but also too comprehensive in that it gives you all sorts of stuff you don't know what to do with. So usually if I want help, I will just Google. And so if I wanted to know about the t-test in R, I would Google t-test in R, and you'll find lots of stuff pops up, some more useful than others. One thing I will say that is important to know if you're learning R is that you might want to select a subset of the data. So we've got these all 10 values together, but we might just want to pick out the values for group 1. And one way to do that is to just put a square brackets with the range of scores you want. So my scores 1 to 5 will give back the first 5 values. I suggest you try that out and check that. And then with that knowledge, you should be able to work out how to do a t-test in a different way, which is with this command, where instead of having the tilde, you just have a comma which separates the two groups of numbers that you want to compare. You should be able to get exactly the same result out with that format if you break up my scores in that way. So that's something for you to have a try with. But that's the end of this session, and we can move on when you've had a chance to explore that.